Hello and welcome back to Boxers Shorts. We are now just over halfway through our series of lessons on Earth's atmosphere. As I mentioned before, this is one of my absolute favourite topics to talk about, both because I think the science itself is interesting, but also because of how relevant it is to our day-to-day lives. And it's about to start getting even more so because we're going to deal with hot button issues like greenhouse gases, global warming and climate change. Now, I can't stress this enough. I suspect a lot of the people watching these videos can feel quite strongly about things like global warming, but it's really important not just to think, oh, this is a problem, we need to sort it out and, strike from school and go on marches and protest and wear placards and things like that. You actually need to know your stuff. There's a lot of people out there with strong opinions about this, and I guess from my perspective, the only thing that's important in terms of those opinions is how much stuff does this person know that's informed their opinion, or are they just kind of mouthing off because it's fashionable, because it's like the done thing. So that's why these lessons should only be seen as a very brief introduction to these issues. They're tremendously complex. There's a lot more to them than we're going to cover in these lessons. But I would encourage you that if this is something that you kind of feel strongly about, or you think it's the kind of thing that you should feel strongly about, the only advice I can give you is just to learn and know as much as you can about it. All right, so let's get started. Greenhouse gases. So what we'll do is we'll draw, this is Earth right here. Okay, that's our planet. It's where we live, in case you didn't know. Around Earth is a layer of gases called the atmosphere, as we know. Now, nowadays, what is the composition of the atmosphere? What are the majority of gases in the atmosphere? So your answer on 3. What are the majority, what are the main gases in the atmosphere today? 1, 2, 3. I'm hoping you said oxygen and nitrogen. So nitrogen is about 80%, oxygen is about 20%. It varies, from place to place by small amounts, but broadly 80% nitrogen, 20% oxygen. There is also a little bit of carbon dioxide, a little bit of methane, and a little bit of water vapor. These are called greenhouse gases. And actually what I'm going to do is I'm going to make the atmosphere look a bit bigger so that we've got more room to work with. So this is our atmosphere. And that's, of course, mostly O2, 20%, and N2 at 80%. We've also got a little bit of what are called greenhouse gases. And here we are talking about carbon dioxide. We are talking about, sorry, those 2 dots should be higher up. We are talking about methane, and we are talking about water vapor. Why are these called greenhouse gases? Well, let's think about greenhouses first. So a greenhouse is, you may not have a greenhouse, but you've probably seen one. A greenhouse is like a little kind of building in the garden that's made of glass, right? And you put plants in your greenhouse. And, this is why I do chemistry, not biology. This is a plant, right? And generally, the kind of plants that you put in a greenhouse are ones that require it to be a bit hotter than the natural climate. Why is it? Because you get heat from the sun, radiation from the sun comes into the greenhouse. Now, ordinarily, that wouldn't be enough to keep those plants warm, and they'd be shivering and they'd be cold and they wouldn't survive. What the greenhouse does is it basically just like traps all of that heat. So the glass, instead of that heat like escaping, it just bounces around and stays inside the greenhouse. It's a bit like why, I don't know, if you're going to a car on a really hot day, when you open the door, you get, oh my God, it's hot. It's because all of the sort of heat from the sun gets trapped in there. And that's what greenhouse gases do. They trap heat from the sun. How does it work? Well, it's a little bit complicated, and you don't need to know a huge amount about it. But, so I'll kind of give you the bare minimum, but please do be aware that everything that I'm telling you is a simplification. So we get radiation from the sun down to the earth. Okay, so we'll write radiation from the sun. Now, you probably have learned in physics that the radiation we get from the sun is has a load of different wavelengths. So there are short waves, there are long waves. Some of the short waves are really bad and horrible, like UV or gamma. And those can cause us really nasty illnesses, like skin cancer. But fortunately, a lot of those get kind of blocked out already by the atmosphere before they ever make it down. But as far as the AQA syllabus is concerned, what you need to know is that a lot of the waves that come down are short waves, and they pass through the atmosphere. True, there are some that don't quite make it through the atmosphere and bounce back, but most of them do pass through the atmosphere. They then get absorbed by the Earth, and then they get kind of re-emitted or emitted again. Emitted means given off. And we say that they get a bit changed by that. So they get absorbed and then they get given off, but as long wavelengths. So I'm just going to write that again because I don't think it's neat enough for you guys. As long wavelengths, like this. And the thing about long wavelengths is that long wavelengths get blocked or reflected. Again, it's a bit more complicated than this. So we'll just go with blocked for the minute. Not blocked, blocked. Now I've lost my G. Long wavelengths get blocked by greenhouse gases. And but simply, what that means is that the greenhouse gases keep us warm because they stop all of that heat from leaving. In the same way that the greenhouse over here kept all of that heat inside, greenhouse gases do a really good job of this as well. If there were no greenhouse gases, a lot of that heat would just kind of wander off into space, and the Earth would be a very cold place indeed. This, in a nutshell, is called the greenhouse effect, and it's how greenhouse gases cause Earth's temperature to be, I guess, increased. And for much of human history, that was it, and there was not much more to say than that. Obviously, in our next lesson, we will look at how humans have been adding greenhouse gases and why that's a problem. But for the minute, all you need to know is just the basic theory of how it works. I think I've got some questions for you here. Yeah, so what I suggest you do is if you copy all of this down, then that should serve as a decent note for you. And again, like I said, it is like a hell of a lot more complicated than this. What I've tried really hard to do is break it down into the most kind of fundamental building blocks and sort of the easiest way to understand it. But again, like I said at the beginning, if you do want to know more, then I really, really do encourage you to start branching out in terms of the things that you know and can do. So copy that down, pause the video, wrong way around, pause the video, copy that down, press play when you are ready. Okay, you should only be listening to my voice now if you did all that. Here are 9 questions. And please have a go at these. Pause the video, have a go at these questions. Okay, so you should have done those questions by now if you are continuing to listen to my voice. And again, I take the opportunity to remind you of the importance of actually doing these questions and not just like passively sitting there and listening to me. This isn't a TV program. This is like a lesson. It's here to help you learn. Right, so I'm going to get my purple pen because that's how I do my marking. How's the radiation that comes to Earth? And that should say, of course, I told you in the previous video that I keep messing that up. How's the radiation that comes to Earth different from the radiation that leaves Earth? So in is mostly shortwave, or there's lots of shortwave, and out is mostly long wave. Okay, not all the energy from the sun reaches every time. Some of it is reflected by the atmosphere. 250 hits the atmosphere at a certain place, but only 128 makes it to the surface of the Earth. How much energy is reflected? So let's go for 250, take away 128, and that should give you what, 122 joules? Yeah, so if I had 228, 230, yeah, 250, there we go, 122 joules. Of course, because the conservation of energy, it doesn't just disappear. So if you let 128 through, then if you let 128 through from 250, it must be that 122 has bounced off. Venus has an extremely thick atmosphere made up of mostly carbon dioxide, so was part of the reason that Venus has a surface temperature above 400 degrees. And you'd say again that carbon dioxide absorbs outgoing, good word, outgoing, which means like leaving, long wave radiation, or long wavelength maybe is better. We should be more precise. Long wavelength radiation. Name 3 greenhouse gases, and you should like try and do this from memory. There's not much point in just going to your notes and going, oh yeah, I know that. Carbon dioxide, methane, and water vapor. Not carbon. Carbon dioxide, methane, and water vapor. Earth's early atmosphere is over 90% carbon dioxide. 3 ways in which that carbon dioxide has decreased over time. So we'll do this quickly this time, but remember, we could easily turn this into a 6-mark question. So we could say that it's taken in by plants and algae in photosynthesis. That's 1. It says locked up in fossil fuels. And we could say it's locked up in sedimentary rock. And that occurred by after dissolving in the... See, here I'm already getting carried away. I promised that we'd do this quickly and simply, and then I'm getting carried away after dissolving in the oceans and forming sediments. Okay, and that's what we looked at, I think, last lesson. Where did the carbon dioxide in Earth's early atmosphere come from? We should know that by now. Volcanoes. Why are scientists not certain how much carbon dioxide was present in Earth's early atmosphere? Again, we've talked about 2 marks for that, billions of years ago. And there's limited evidence. Okay, and finally, describe how carbon dioxide maintains temperatures on Earth. So maintains means like to keep or control almost temperatures on Earth. Got 3 marks, we'll do 3 points. So we'll do short wavelength passes through the atmosphere to Earth, and then it's emitted or reflected or given off as long wavelength, which in turn is absorbed by carbon dioxide. So I guess the key thing here is that the carbon dioxide is almost like, it's like a gatekeeper. So you have the carbon dioxide is like this, and the short gets through here, lets short through, but it doesn't let long through. Okay, so not long. I think I made that mistake twice now today. Or was it something else? Anyway. All right, you get the point. Okay, so that's all we've got time for today. I remind you to make sure that you've done all the activities, go back over them if you weren't sure about anything. In our next video, we will look at human contributions to greenhouse gases, which is where things start getting interesting. Well, I think things are interesting till now, is where they start getting really interesting and also a little bit depressing. And yeah, make sure to subscribe if you want more videos like this, and let me know in the comments if there's anything more I can do for you. Be well, bye now.